You're listening to ARC Advisory Group's The Sustainability Podcast, where we explore how artificial intelligence, industrial sustainability, logistics, supply chains, and smart cities are shaping the future. In every episode, we talk with industry leaders who are finding practical ways to create more sustainable solutions. Whether you're a business professional or just curious, these conversations will give you fresh ideas on how to reduce environmental impact while improving efficiency. From smart technologies to rethinking supply chain strategies, there's always something new to learn. If you'd like to go further and make a real difference, be sure to connect with ARC Advisory Group. Our expertise can help your organization adopt cutting-edge sustainability strategies that drive both innovation and results. Don't miss the chance to stay ahead and make meaningful changes for a more sustainable future.
Recording live from the ARC studios, welcome to the Sustainability Podcast. Our goal is to provide engaging discussions on a broad range of topics regarding cybersecurity, sustainability, supply chain management, plus much more. For more information and to get into contact with us, visit us at arcweb.com.
Welcome to the ARC Advisory Podcast, where we explore the intersection of technology, digital transformation, and sustainable practices. In today's episode, we're diving into the fascinating world of industrial AI. We'll be unraveling the differences between industrial AI and general AI, and discuss how AI tools and techniques are specifically tailored for industrial applications. From the origins of the term industrial AI to its impact on people, processes, and technology, this episode offers a comprehensive introduction to the transformative power in the industrial sector. Stay tuned as we explore the industrial data fabric, the nuances of supervised and unsupervised learning, and the role of causal AI in enhancing transparency and reliability. Today, I'm very pleased to be here with ARC's Senior AI Analyst, Colin Masson. Colin, how are you today?
I'm great, and I'm looking forward to answering your questions, many of which I know you've received from our clients.
Yeah. So let's tackle the fundamental concept. What is industrial AI, and how does it differ from general AI?
Well, the first challenge is what is general AI? And as I've been doing my research and interacting with a bevy of data scientists and AI experts across various disciplines, data scientists, would-be data scientists from the industrial domain. One thing I've discovered is that there is not a definition that everyone can agree on. So I think that's one challenge. Another challenge is that the popular press has kind of grabbed onto generative AI and almost de facto to them, that is what is general AI, is this new era of breakthrough in generative AI specific tools and techniques, large language models to many. That is what general AI has become. And in our world of engineering, process control engineers, electrical, mechanical, chemical, whatever your discipline, if you're in the industrial sector, then AI is not new to us. It's been around for decades. I myself worked on neural networks 20 odd years ago. And so really, industrial AI is more about the application of a wide range of tools and techniques, but from the data science, computer science disciplines, and all of the different machine learning, neural network, you name it. There's a whole collection of techniques that go back to the 1950s, right? In terms of the evolution of AI, and many of them have been applied to industrial AI use cases. And I think that's when we talk about industrial AI, we're really just trying to get everyone back to, okay, it's the application of one or more AI tools and techniques to solve a specific business problem, or not necessarily solve it. More often than not, it's about providing additional insights and actions that augment people's ability to deal with the massive amounts of data that we generate in those industrial use cases. So hopefully that's a basic explanation of industrial AI versus this loose term of general AI.
Colin, that leads me to another question. Why was the term industrial AI coined by ARC? And how does it distinguish between general AI and AI specific to industrial applications? What was the underlying need to counter that hype around generative AI?
Well, thanks, Jim. You kind of half answered the question yourself in terms of the hype, right? The November 22 release of ChatGPT 3.5, I think it was at the time, was kind of a breakthrough, or a perceived breakthrough, in accuracy of large language models, and that's kind of caught the attention of the popular press. And it's driven a massive infusion of investment in the broader field of AI. But along with that, it's created a lot of confusion about which form of AI should you use to solve a particular problem. And we saw this very much in the industrial sector, where AI has been broadly applied for decades. Techniques like machine learning and neural networks and computer vision for identifying quality defects, for example, is broadly applied. And we've seen use cases like predictive maintenance and the aforementioned quality management. So it's not new to us, but it created a lot of confusion in the industrial sector. ARC was getting a lot of questions about generative AI. How do I use it? How do I apply it? And should I be applying that instead of techniques that I understand and have applied and have a high accuracy already? So we felt the need to really define industrial AI as that collection of AI tools and techniques that apply to industrial AI use cases, which by definition mean they have to be high accuracy, in most cases, because the processes that they're helping provide insights on and helping people make decisions on have major health and safety implications, as well as clearly the usual business in terms of customer satisfaction and profitability. But in our sector, industrial AI, kind of hidden in that definition, and some vendors have picked up on it. We've talked a lot about the fact that AI needs to be industrial grade. The data quality needs to be there. The accuracy of the recommendations needs to be there. We need to meet strict quality, safety, security, compliance requirements in our industrial applications of AI. And so we've really used industrial AI just to remind everybody that Gen AI is just one tool in the industrial AI tool set, and that you should be picking the right AI tool and technique to develop each skill and each set of insights that you need to solve particular business problems.
So, Colin, what are some of those AI tools and techniques used in industrial settings? And how do these tools, like machine learning or deep learning, fit into the larger industrial applications market, can you perhaps explain the role of natural language processing and computer vision as well? There's a lot there.
Yeah, that's a broad question. And industrial AI really can use more than one tool and technique. It's not either or in this field. I mean, that's why we need data scientists, and we talk a lot about industrial grade data scientists, people that understand the industrial domain. In other words, they understand manufacturing, supply chain, product design, process design. They need to understand the very specific requirements of the industrial domain, along with some of our compliance, security, safety, and health considerations. But they've got a lot of tools at their disposal. And we've been using, and frankly, a lot of AI is kind of started with symbolic AI. If you remember, kind of heuristics, rule-based expert systems. Symbolic AI was all the rage back in the 50s, and that was the pervasive AI tool and technique for decades. And I'm not going to go through the whole history of the evolution of AI, but to a large extent, machine learning addressed the fact that that those systems just got too complex and too difficult to maintain, and they weren't adaptive. And so really machine learning kind of took over as we had more and more access to data. The cost of accessing that data and processing that data got cheaper and cheaper, particularly with the advent of GPUs and their applications to a number of machine learning tools and techniques. But you've kind of got machine learning, neural networks, various forms of neural networks, whether they're kind of convoluted, artificial neural networks. There's various techniques that get deeper into deep learning techniques. And then you get a lot of specific applications and optimizations, if you like, of algorithms and approaches to training that really are optimized, let's say, for natural language processing, which are used broadly in consumer. We're used to talking to devices now and being somewhat understood. So that's natural language processing, but it has a lot of applications in manufacturing when you need to keep your hands free. Then you may need to talk to a system to get it to perform an action for you. Or you may be trying to communicate in noisy environments in manufacturing, and so it can help with enhancing communications in a number of use cases. So there's a lot of applications of natural language processing and voice recognition systems broadly. Then you have kind of, sometimes it's called machine vision, sometimes computer vision, but basically taking video or pictures and being able to process those, do object or shape recognition, and beyond that, kind of looking at, is somebody using a camera, is somebody moving into a hazardous environment, or are they not wearing a hard hat or other safety gear, or can be used for security, intrusion, or loss prevention type use cases. So there's a number of applications of kind of that computer vision or machine vision. Very often it's called machine vision when you're looking at industrial use cases, because it's clearly a skill that robots need to have. As they're moving around and interacting, they need to be able to recognize objects and shapes. So computer vision or machine vision is a major field that if you were at Hannover Messe this year, you will kind of have seen the rediscovery of machine vision. That was kind of, I wouldn't say anything net new, but just a lot more of them, a lot more accurate. Clearly the the cost of using machine vision has come way down with all of the other investments in AI infrastructure and the advancements we've made in being able to process massive amounts of data and the fine-tuning of all the models for computer vision. So hopefully that gives you a sampling. That wasn't by any means comprehensive. We might want to talk about deep learning and
very good.
Yeah.
No, that was very illustrative. So, Colin, of these AI tools, how are they impacting people, processes, and technologies in the industrial sector? What specific business processes are being affected? And how does AI enhance technologies and most importantly, improve business outcomes?
Well, we saw even before November 22 and the perceived breakthroughs in generative AI, in our annual survey that we do, we really saw over the last couple of years that AI was perceived by our industrial customers as the most impactful technology. And so we kind of followed up on that with specific research into what were the use cases, to your question, for AI in the industrial sector. And we actually got validation of at least 25 industrial AI use cases. We kind of looked at 5 in 5 key domains. We looked at 5 in kind of the customer sales and service domain. We looked at 5 in the supply chain, planning and execution domain. We looked at 5 in kind of production, core manufacturing or energy production. We looked at 5 that were really about skills and augmenting the workforce. And then we looked at 5 use cases which were around product and process innovation. And so I can't talk about all 25, but let's say the top 2 were not a big surprise to us, but the top 2 that we saw in production operations were really around predictive maintenance and quality management. And they use 2 different sets of AI tools and techniques. So predictive maintenance is very much about using machine learning. And then when we look at quality management, that was much more about using computer or machine vision techniques to detect defects. Although in some cases it's being used together, right? Because they're looking at the quality results and trying to correlate back to what they actually saw in the process. So it's a great example of where really you can use multiple AI tools and techniques to solve a particular use cases. Now, the most pervasive across almost every industry, partly because it was the first to migrate to the cloud, and it has almost become, you can't call it cloud native because it didn't start there, but it's kind of the showcase or the poster child for cloud migration is really in the sales domain, where almost everybody, whether it's in their CRM system where they bought a best-in-class customer relation management or field service management solution, and they're getting infused AI capabilities like chatbots and assistants that tell them what to sell next or how to prioritize customers or how to route their field service agents. They're getting AI infused in their sales and service applications, or even if they're using their ERP sales and service capabilities, they're doing the same thing. They're kind of infusing the ERP vendors are infusing their solutions with a set of AI capabilities. So that's probably, if we really took our kind of there's more to the industrial sector than making stuff. We still have the full business to run, and we still have customers and service interactions then. And that's probably the leading application in the industrial sector as well.
Colin, many of us in the industry are hearing about the industrial data fabric. So what is the industrial data fabric? Why is it important? How do these frameworks integrate various AI models and techniques? And what role do they play in this context?
Well, we put industrial data fabric, we being ARC, when we really looked at the impact of people, process, and technology on the industrial sector. We kind of built out this framework. We've defined industrial AI as the collection of tools and techniques that are used to bring intelligence to people and processes in specific industrial use cases. So we've tried to make sure everyone remembers there's a massive amount of opportunity beyond generative AI in the industrial sector. But as we built out that model, no surprise, it became clearer and clearer that our opportunity in the industrial sector was that we had, or we have, and we generate massive amounts of data. So, we spent the last decade or more in digital transformation, in trying to connect machines, or sensors, equipment, machines, production lines, factories. We've been trying to connect them all to be able to digitize the data coming from them, digitalize the processes that run our factories and run our supply chains, run our service management processes, etc. So the opportunity is there, but we haven't done a great job, at least at the factory and production level, of really ensuring that data quality as we've been going through the process. Yes, we're enhancing data quality, but we still have lots of machines that are not connected, lots of factories that are not connected, or they're connected, but we're not really adding context to the data. We're not really great at driving standards, particularly in factories. We as ARC engaged in a number of those efforts to try and improve the situation. We're active on the SESME advisory board that's trying to drive standards for smart manufacturing. So we all recognize the problem, but if we're really going to tackle the AI opportunity, we can do garbage in, garbage out at an enormous scale now, thanks to the power of the cloud and these AI solutions. But that's the last thing we need is garbage out, right? And so in fact, I put an extra word in there. We talk very much about the need for industrial grade data fabrics that really help us manage the heterogeneity of the data that we have in many of our industrial use cases, and the added challenge that a lot of that data is on the factory edge, if you will, or it's really being produced at the factory edge, and a lot of it will stay on the factory edge for the foreseeable future. It's not all going to get moved to the cloud into a massive data lake, which is kind of the approach that enterprise data fabrics take and assume. So the born in the cloud, if you like, data fabrics make that fundamental assumption that you've got well understood data, usually fairly structured data coming from ERP systems and supply chain systems, or even our customer management systems, where there's a lot of commonality and standardization on what effectively at that point is largely transactional data that's well understood. We have a different problem in a lot of our industrial AI use cases where a lot of the data is at the edge. We can't afford to move it to the cloud, or there are data latency and security concerns about moving it all to the cloud that mean that many of our use cases are hybrid or edge-based, and therefore it's a specific problem that we need to deal with in what we're calling industrial data fabrics that understand everything from time series data to some of that machine data, which may be vibration data, there may be visual data that we're capturing. Cameras are being deployed pervasively, camera sensors for a lot of machine vision use cases, robotics, drones for visual inspection. So, we're getting a lot of the mixed data types coming in, every data type. Plus, we have that added complexity of a lot of it is massive amounts of time series data that doesn't have a lot of context without doing a bit of work, which is what we expect industrial data fabrics to help with. They'll help with adding context to that data, helping to build the models that will then be used to train some form of AI system, not necessarily a generative AI large language model. In a lot of cases, it will be classic machine learning, neural net techniques, or causal AI, or neurosymbolic AI techniques that are better at solving math and physics problems.
Colin, in this industrial data fabric domain, can you comment about and contrast supervised learning versus unsupervised learning? What do both of those terms mean, and how do they differ from each other?
I would probably add maybe reinforcement learning to the mix there, and I think the key thing about these various learning techniques is really whether or not where they're used in the phase of development of AI systems is one factor. So if you talk about unsupervised learning, I tend to think about that being used for exploration. Very often it's used for clustering or looking at patterns in data, and then you still need a data scientist very often to either tune that exploration of those patterns. So there is some form of supervision, if you like, but it is able to go and look at and identify a lot of patterns and maybe do some of that clustering. And then data scientists will decide what's the next step and how to use that data. So it tends to be used more for exploratory, but there are other techniques. You talked about supervised, and kind of if we look at supervised learning, it's kind of the dirty little secret of AI, if you like, that a lot of these high accuracy AI solutions are high accuracy because you had a massive amount of people behind the scenes labeling data. And what do we mean by labeling data? Well, they're looking at pictures and identifying for the AI that is a dog in a photograph, or it may be, the classic example is autonomous driving, right? A lot of the training involves people looking at videos taken by these cars with all that, the LiDARs and all the equipment on them, and then either there may be some automated labeling, right? Because the AI can do certain things, but there's a lot of validation and checking that, yes, that is a traffic sign, right? That was a stop sign, that is a yield sign, that is a car in front of you, that is a lorry, whatever you're really identifying and training by actually labeling a lot of the data, that it then knows this is one of those stop signs. This is a particular thing that it can understand. And then in between, you've kind of got various forms of reinforcement learning where it's more automated, but you may have people that are pointing it in the right direction, or it's doing things by trial and error where you will tell it, no, that is not correct, and it will keep trying to get the right answer, and you will tell it the right answer. So there's various forms of people engaged, and I guess it's more about, is it people, relatively low-cost people doing massive amounts of labeling, or is it very smart data scientists using and guiding unsupervised learning or various techniques to try and extract more from data without that massive involvement of teams of people or factories? I mean, there's the hidden AI factory, as some people call it, is really all of those people around the world that are being asked to label data to help with improving accuracy and training AI systems.
Colin, what challenges arise from using AI in the industrial domain? And I'm thinking broadly about explainability, transparency, some related issues like that, particularly in the context of mission critical processes and applications. Can you talk about that a little bit?
Yes, I think you've seen from a lot of the campaigning about making AI systems more transparent and explainable. I think where the industry as a whole will eventually go, but why in the context of industrial AI, we keep coming back to it needs to be industrial grade. It needs to be traceable. Any decisions, because if you're using an AI now to make decisions about production, things that may impact safety, that may impact compliance with regulatory requirements, that may frankly impact people's productivity and maybe their livelihoods. I mean, there's ethical aspects to this as well, but regardless, there's great concerns about the black box that is generative AI. A lot of the approaches in terms of training, and this applies broadly to machine learning in general, or machine learning techniques. They have the benefit of being able to identify patterns and are much lower cost for delivering AI solutions, but you don't always understand how they are making decisions. So the root cause analysis, and so I think you hinted at this idea of causal AI. And so there's a whole branch of AI where the systems that are being developed are inherently developed so that there is traceability, that you can do the root cause analysis and say what contributed to making that recommendation or that decision. And hopefully it wasn't a decision, there was a person in the loop that approved that decision, let's say. But there are clearly systems that are sometimes closed loop, and there are those that still there's enough safety or security impact or profitability impact that we still have people that really have to sign off on a recommendation that may be made by an AI system. Sometimes we hear it referred to in the EU with their regulatory push for AI, and in the US as well, although I'd say EU is perhaps more further ahead in terms of trying to drive for this, is really explainable. So, and there's lots of use cases. I don't know that we have time to go through many of them, but there's been many use cases where bias introduced in a AI system, very, very well-known one about, let's just say, a hyperscaler that employs a lot of people was using AI to review resumes that are being submitted. And without knowing it, they'd introduced a bias because it was trained on data where there was a preponderance of, let's just say, not ethnically diverse candidates selected. And because they trained on that, that's what ended up being in the AI system. So it was kind of reinforcing bias in those systems. And imagine now that you don't get a job or you are passed over because an AI made that recommendation. There's actually much worse examples that I don't really want to call out any particular company for having tried that particular approach. But more and more we're seeing these use cases where the AI either had a bias or was not trained adequately, and therefore people made discriminatory decisions or made the wrong decision. So with this push for explainable AI, it's kind of reinforcing, I think, what the concerns are or what the challenges have been with industrial AI use cases, in that we have to train them on very specific proprietary data on specific machines, and validate those models are accurate. And very often it's a process of introducing them that involves people, that involves working with your operators, your supervisors to make sure those go into production and that they trust them. And so there's always this element of they want to understand why certain recommendations are being made. So we very much have seen the resistance to black box approaches. And so I think we'll see more and more this push for causal AI, or the other challenge we've seen is the need for math and engineering accuracy. So machine learning techniques applied to very narrow AI problems, you can keep the accuracy up there. As you get to bigger and bigger and more complex problems, then things like generative AI are not great at solving math problems, right? They were designed and optimized for large language models, right? They were really optimized for to some extent, not natural language processing, and also they are designed to be creative and generate new ideas, and we need predictability and accuracy in a lot of our use cases. So techniques like neurosymbolic AI, which kind of blend the benefits of approaches that are taken in generative AI, doing deep learning neural networks, to process massive amounts of data and look for patterns, but then to apply rules or symbolic AI blended with that to make sure we get high accuracy that we can solve. We're getting closer and closer to solving real math and engineering problems with neurosymbolic AI techniques now. Then I think we'll see more of that branch of AI take off. But I think hopefully you're getting the sense that it's not simple. There's a wide range of techniques. You do need data scientists to a large extent to be involved in picking the right tool and technique. You need to train on specific data. So we've got lots of successes in the industrial sector, but not at scale. And so I think that's the big challenge, is how do we get to the point where instead of pointing at one or two successes, great pilots, or even great solutions that solve a very narrow problem with a specific set of machines and equipment and processes, can we take advantage of the AI evolution or revolution, depending on how you want to term it, and start deploying scale across a wide range of industrial AI use cases?
Colin, I'd like to drill down a little bit more into mission critical applications, and many industrial processes are mission critical. So in terms of causal AI, how exactly does it provide root cause analysis and traceability? Because that's one of the major concerns today about AI. Can you, I mean, I know you talked about it in a variety of ways, but can you give us some specificity there?
And I think at the root of your question is really that we're seeing a lot of traction or a lot of interest in causal AI because we need traceability, explainability of recommendations that are being made. And the proponents of causal AI really tout its benefit because it's kind of a data-driven approach. It really starts with looking at data, the principal components that are really the principal variables, the confounding variables. In other words, all the components of that data set that are contributing to various outputs. And of course, there's a lot of work that goes into building the causal AI model that really involves building a model of the problem domain that you're trying to solve. But they very much make those connections from the ground up, if you like, with, for example, working with one proponent of that technique, the causal AI technique. They're really able to trace and make recommendations on procurement decisions, on buying certain materials, because they've made the connection by linking their data sets in production. And so they understand it's not just about cost, they understand which attributes of a particular material impact their production process, because they've linked these data sets, they've contextualized them, they've kind of broken them down into a specific business problem and all the variables that may contribute to making that decision. And so they kind of have an approach that really then lets you do a drill down through the data. So inherently, you have the root cause analysis, right? You can drill back through the data at every step of a decision or a recommendation that's made. So it fundamentally takes a data-driven approach, contextualizing all the data to a specific problem domain. And of course, that means it may also have scaling limitations, right? Because you're applying it to a very specific set of your data. But that's clearly a path that many want to follow because it taps into your IP. It's very specific to your set of business problems, how you run your business, how you want to prioritize and shape particular directions. So if you want to introduce more sustainability, it's one way where you can kind of look at the impacts on sustainability and shape those decisions by adding those insights and providing them to the right person in the right organization as they're making those decisions, and are able to drill through. If they don't understand it, they can drill through and see, all right, why is this a better decision to achieve my sustainability goals? So causal AI in particular, I think, has its set of proponents. Can you achieve like any of these techniques, can you apply it to every use case in your business? Yes, potentially you can. Is it the right one to apply at the right cost? It can be very data intensive and expensive and take you a long time to build that insight across your business. And that's where you'll want to blend different tools and techniques to achieve your business goals for each industrial AI use case.
Colin, let's shift to applications. So how are industrial organizations adopting AI technologies today? What are the trends in AI investments among these organizations? And what do some of ARC's surveys in the domain reflect?
So we did a survey of 525 industrial organizations, and obviously we talk to many of our clients on a daily basis about their applications of AI to a wide range of problems and opportunities to achieve outcomes in their businesses. But what we found from those conversations and that survey of 525 industrial organizations is that there is broad application, in fact, perhaps broader applications outside the factory than inside the factory or your production facility, whether you're manufacturing goods or producing energy or in the oil and gas domain. So very often they're applying them. It's pervasive in customer service applications. And I think we're all used to that in our daily lives as well. But imagine now you have a complex multi-million-dollar machine or production line or a factory and you need support and service around that. It's very specific. They tend to be highly configured products for each of their customers, and so in many of the industrial applications, then having that ability to mine your internal systems for all the data about what you built for that customer, all the components of the machine that you delivered for that customer, and its applications and how they can optimize it, reduce energy consumption from it. You can see the potential for a broad application of AI, everything from Gen AI to go and look at documents that you may have in existing applications and knowledge bases to basically get, looking at Teams conversations and previous calls. So there's lots of ways that you can actually apply AI to help digest that information and make it much more accessible in near real time or service time, if you like, for the service use cases. So we see very much that being an ongoing and fast evolving application of AI. But everything from enterprise applications, right? I mean, SAP has its vector engine. It has tens of thousands of customers that are allowing them to train their vector engine using their data. Obviously, it's anonymized, and there's various techniques so that customers are willing to do that. But SAP is doing that. Infor has really built their multi-tenant ERP platform in a way and got contracts with customers that mean they can get access to a lot of that data and train their processes and get process optimization, process intelligence, and deliver that back to customers on an ongoing basis. So it's getting moving fairly fast in the ERP application space as well. Fields like asset performance management, then we might think predictive maintenance, everyone's already done it. That's not true, right? It's probably the most common use case of AI, but we still haven't seen it broadly built into every asset performance management or enterprise asset management solution. And so there's still opportunity there, but clearly lots of opportunity to take the data that you can connect from machines and connect it with the maintenance data and continue to enhance in that direction. So predictive maintenance and quality management kind of lead the pack in terms of vendors trying to come up with scalable applications of AI in production. But other areas that we're seeing, I think you will see develop a lot in the future, whether it's Siemens or Rockwell or Schneider. I'm sure I'm going to leave out somebody who's going to be unhappy. but lots of the industrial automation vendors are really looking at how do you, do the customer service, right, where they're all basically starting to improve their service to customers by doing what we said earlier, which is really taking knowledge bases and making them much more accessible to their end customers. But they're all exploring as well, how do I put AI on the edge? Rockwell just made a lot of announcements about their plans for rolling AI into almost all of their edge solutions so that you can basically start to make lots of inferences from data that is collected, and the inferences can be made on the edge. But they're also talking about how they're going to make programming PLCs, right? Siemens is moving in a similar direction where really, PLC programmers don't come out of universities, right? So one of the limitations of really applying a lot of industrial automation technology has been the skills required for very proprietary programming languages, in effect, to really scale out that deployment of automation. So they are working with the Microsofts and the AWS, and in the case of Siemens as well, to really take a lot of the application of generative AI and its ability to understand language and help with coding, but now applying it to their specific language requirements. And so you're seeing some real innovation, and I think a lot more to come in terms of making it easier to interact, integrate with, deploy industrial automation systems that have traditionally been complex and proprietary, and are still in many cases complex and proprietary, but it will become much easier to get those skills or to be aided in developing those skills using AI. I could keep going on, but hopefully that gives you a flavor of some of what's going on and some of the
That's
applications.
Good. Thank you. Colin, from a strategic perspective, there's been growing discussion in the industry about a digital divide in terms of digital transformation generally and AI more particularly. Can you speak to those points a little bit?
Yes. The digital divide is a concept. I think we've all heard the term. I think we may think about it in social terms. But the way we're using that term, and we published a report looking specifically at the digital divide, because we've been working for a decade with industrial customers on their digital transformation journey. And so there has been this digitalization effort in the sector, and it's been going on for a number of years. Now, during the pandemic, we saw an acceleration of that. I think all the data from our various surveys showed that there was a doubling down in terms of connecting machines, in applying a broad range of technologies, not just AI, but AI up to the list. So in our annual survey, AI has been the most impactful technology, helping them with that journey over the last couple of years, and it jumped by 35% in our end-of-year survey at the end of 2023. So it's, if anything, AI impact has accelerated as part of that journey to digitalization. And what we explored in our report on the application of industrial AI broadly, so the broad set of tools and techniques that we call industrial AI, is we wanted to see specifically, was that widening that digital divide, and maybe I didn't make it clear, that digital divide, we see leaders further along on that journey, the pandemic, those that were ahead, right, before the pandemic were able to go further because they already had digital processes and could do a better job of remote work, and that blend of people that still had to go into the factories but supervising or helping with experts that couldn't go into the factories. So they stretched that lead. Those that doubled down on investments during the pandemic either caught up and became those leaders, or if they were already leaders, kind of widened the gap between them and the mainstream. And so our hypothesis was, surely if you're further ahead on your data digitalization journey, you're probably now going to widen the gap because you can now make faster progress with those industrial AI use cases because you've already got some of the industrial data fabric that is at the core of our model of the impact of people, processes, and technology on industrial use cases. And so the hypothesis was validated, right? What we saw was that across 25 industrial AI use cases that we measured, the leaders were 30 to 40% ahead in their deployment of those use cases. And if we projected where they were going to be, or they projected, in effect, where they were going to be 3 years out, that lead was going to widen. So, in effect, the digital divide hypothesis we validated with data. Now, beyond that, how do you catch up, right? And so I think that's really where we also looked at, well, why were they leaders? It was clear to see they were further ahead in deploying industrial AI use cases, and there were a few things we looked at, like governance was one key differentiator, that the leaders were more likely to have a corporate governance program that had integrated. There was a people approach that was quite different, that really the leaders were also investing in skills. So yes, in recruiting AI talent, but also in investing in AI talent. So they were training their people, they were building up an army, if you like, of data scientists, or I group them together. They may not be industrial grade data scientists who understand both domains, but by getting a mix of people that were being trained in OT and engineering technology, ET, and the IT domain, and recruiting data scientists and mixing and matching, they kind of get that blend. That means you do have industrial grade data scientist capabilities in the organization. So that was another attribute of the leaders. Another was the fact that they were investing in that, whatever you want to say is the mix of things that really makes an industrial data fabric. They said they were focused on ensuring data quality and in data fabric capabilities. So I think those were three of the key attributes that we saw that leaders were doing. So applying AI, but the way they were governing it, the way they were investing in people, and their approach to some specific technology investments like the data fabric and ensuring data quality were some of the ways in which they were widening that gap.
Colin, given all we've covered today, I'd like to go back to a conversation we had that was not on the recording today. And let me ask you a question you asked me earlier, is that the adoption of AI in the industrial domain, is it evolutionary or revolutionary? You go first.
Okay, you want me to go first? Well, I guess I wrote the first report with that question essentially embedded in the title, right, where I called it the Industrial AI Revolution, but the R was in brackets, right? And so when I went into writing that report on behalf of ARC and working with a number of our analysts, there was a heated debate, right? Now that was written over a year ago now, right? And so if I look back on it now, I can say that I think it is an evolution in terms of AI tools and techniques, right? Because I still talk with many clients, both kind of industrial manufacturers, those in the oil and gas segment, etc., and with vendors trying to apply AI. Broadly, the feedback I get is 80% of the use cases they're looking at, they're still applying more traditional, or let's say more mature, AI tools and techniques. So the idea that generative AI has revolutionized even AI, let alone the industrial sector, is a bit of a stretch. I think it's more of a evolution. I think where I tend to lean towards it being maybe revolutionary is in one very specific way in which generative AI is impacting the way that we interact with complex systems. And so whether it's in our daily lives, where I typically I don't use Bing or Google for search anymore. I'm using Copilot, right? And so I have a whole different way of interacting when I'm looking for data, researching data. So that's just one use case, right? But we're all starting, whether we realize it or not, we're interacting with more and more Gen AI powered chatbots, experiences. We're talking with vendors that are now making it the de facto way that you will interact when you work with their technology. They're trying to use it to make it much simpler, to ramp up, to get help. And in some ways, it's becoming the new. And so I think in that way, it's like mobile phones before it, right? Before that, we would much more comfortable interacting on a desktop, right? And then we had to account for the fact that, well, now everyone's most powerful device they probably have is their phone, right? And that's the way they interact. And you had to change the UIs. You had to introduce voice. You could introduce video. And I think take the idea that really any complex system, whether it's on the shop floor, in the factory, in supply chain, they all have to process massive amounts of data. They're getting more and more complex. And so it's revolutionary in the terms of it's changing the way that almost every software, hardware, the fusion of the two in complex systems is being designed, and the way that we will interact with them from here going forward.
Well, thank you, Colin Masson, the Director of Industrial AI here at ARC Advisory Group. This is the first of a 4 or 5 part series on industrial AI. And thank you to our audience for joining us on this journey into the world of industrial AI. We've covered quite a bit today, from the fundamental differences between industrial AI and general AI to the impact of AI on industrial processes and technology. If you did find this episode insightful, be sure to subscribe to our podcasts. That would be ARC's The Digital Transformation Podcast, as well as ARC's The Sustainability Podcast, and leave a review. Of course, please share this episode with colleagues and friends who might benefit from the understandings that we've learned today. And stay tuned for more episodes as we continue to explore how technology, and AI in particular, is driving sustainability and digital transformation. Thank you very much for joining us today. Thank you for tuning in to the Sustainability Podcast. Today, we explored how artificial intelligence, logistics, supply chains, and smart cities are revolutionizing sustainability efforts across industries. Now's the time to take what you've heard and start implementing those changes in your work. Please share this episode with others who are passionate about building a better future and keep the momentum going. For those looking to go deeper, ARC Advisory Group offers unparalleled guidance in developing and executing sustainability strategies. Please reach out to us for expert insights and support that can help you turn these ideas into action and to lead your organization towards a more sustainable path.